Welcome all. We can start this elementary quantum mechanics. Today we can see Planck's radiation law. This scientist Planck's, he can give this law. So Planck's put forward his theory to explain spectral distribution of black body. Planck's put forward his theory to explain spectral distribution of black body. Already we can see that what is meant by black body. If a body absorbs all the radiations that fall upon it, it is called as a black body. And the radiation emitted by such a body is known as black body radiation. Okay. So Planck put forward his theory to explain spectral distribution of black body. So according to Planck's theory, an oscillator absorb or emit radiation. An oscillator absorb or emits radiation discontinuously in the form of energy packets or bundles called quanta. Okay, this is the first we can say that according to this Planck theory, he can say that an oscillator absorb or emits radiations discontinuously. Continuously radiation emit नहीं करते हैं, तो ये discontinuous रहेगा, and it is in the form of energy packets, or we can say that in the form of bundles. These are called as quanta, जिसको आप क्या कहेंगे, क्वांटा ऐसा कहते हैं. Secondly, quanta may be considered as behaving like a stream of particles. Quanta may be considered as behaving like a stream of particles. और these particles, ये जो particles रहेंगे, these are having mass, energy and momentum. ठीक है, quanta may be considered as behaving like a stream of particles, and these are having mass, energy and momentum. The energy of a quantum of radiation is given by E is equal to h mu. Understand? The energy of a quantum of radiation is given by E is equal to h mu. Here E is nothing but the energy, mu is nothing but frequency, and h is nothing but Planck constant. और h यानी कि क्या रहेगा, Planck constant रहेगा. And lastly, the oscillator has definite amount of energy in discrete levels called energy levels. The energy En of the nth energy levels will be an integer multiple of a quantum, that is En is equal to n into h mu. The oscillator has definite amount of energy in discrete levels called energy levels. The energy En is written here 1 2 3 4 like that. The energy En of nth energy level will be an integer multiple of a quantum. If here n is equal to 1, then E is equal to h mu. If n is equal to 2, we can say that E2 is equal to 2 h mu. Listen. So here that energy En of the nth energy level will be an integer multiple of a quantum. This is about that Planck's radiation law. ये 4 स्टेटमेंट्स है प्लैंक्स रेडिएशन लॉ के. तो दिस प्लैंक्स रेडिएशन लॉ जो है ये 1900 में लॉ दिया गया है. And the scientist Planck, he can put forward his theory to explain spectral distribution of black body. So according to this theory, according to, we can say that Planck's theory, he can say that an oscillator absorb or emit radiations discontinuously in the form of energy packets called quanta. Second statement, quanta may be considered as behaving like a stream of particles possessing mass, energy and momentum. थर्ड जो है, the energy of a quantum of radiation is given by E is equal to h mu. Here h is nothing but Planck constant and mu is frequency. The last statement is nothing but the oscillator has definite amount of energy in discrete levels called energy levels. The energy En of the nth energy level will be an integral multiple of a quantum, that is En is equal to En into h mu. Then we can say the photoelectric effect. Okay, photoelectric effect. This is the diagram. एक डायग्राम है. This is nothing but a metal plate. ये metal plate रहेंगे. This is nothing but the, you can say, photon stream. Actually it is nothing but the ultraviolet light. UV light रहती है ये. This is also the metal plate. This positive charge, this is negative charge. It is a voltmeter. This is ammeter. This is a battery, rheostat. ठीक है, this diagram. हाँ, actually what is the photoelectric effect? When when a beam of light of sufficiently high frequency is allowed to strike a metal surface in vacuum, electrons are ejected from the metal surface. This phenomenon is known as photoelectric effect and the ejected electrons as photoelectrons. The photoelectric effect यानी क्या रहेगा? When a beam of light, this is nothing but a beam of light, we can say that it is ultraviolet light, a photon stream. When a beam of light of sufficiently high frequency, condition क्या रहेंगी? Of sufficiently high frequency is allowed to strike a metal surface in vacuum. ठीक है, this when a beam of this light, sufficiently high frequency beam of light of sufficient high frequency is allowed to strike a metal surface. ठीक है, ये मेटल सरफेस पर जाकर गिरने के बाद में क्या हो जाता है? What happens? Electrons are ejected from the metal surface. Electrons are ejected from the metal surface. This photoelectrons released from the metal. तो मेटल जो है वहां से क्या हो जाता है? इलेक्ट्रॉन जो रहेंगे दे आर इजेक्टेड फ्रॉम द मेटल सरफेस. तो दिस फिनोमिनॉन इज नोन एज फोटो इलेक्ट्रिक इफेक्ट. ये जो फिनोमिनन है इसको ही क्या कहते हैं? फोटो इलेक्ट्रिक इफेक्ट कहते हैं. एंड द इजेक्टेड इलेक्ट्रॉन्स एज फोटो इलेक्ट्रॉन्स. ये जो इलेक्ट्रॉन्स है दीज आर इलेक्ट्रॉन्स आर नथिंग बट दी फोटो इलेक्ट्रॉन्स. इसको ही क्या कहते हैं? फोटो इलेक्ट्रॉन्स कहते हैं. अंडरस्टैंड दिस फोटो इलेक्ट्रिक इफेक्ट. It is simple. When a beam of light of sufficiently high frequency, when a beam of light of sufficiently high frequency is allowed to strike on a metal surface in vacuum, what happens? Electrons are ejected from the metal surface. ये इलेक्ट्रॉन जो है कहाँ से इजेक्ट होते हैं? ये मेटल सरफेस पर से इजेक्ट होते हैं. तो दिस फिनोमेनन इज नोन एज photoelectric effect and the ejected electrons as photoelectrons. Understand? देखो ये beam of light है. When a beam of light of sufficiently high frequency is allowed to strike on a metal, ठीक है, मेटल पर जाकर गिरने के बाद में क्या होता है? मेटल सरफेस इन वैक्यूम. इलेक्ट्रॉन जो रहते हैं इलेक्ट्रॉन्स आर इजेक्टेड फ्रॉम द मेटल सरफेस. तो ये इजेक्टेड जो इलेक्ट्रॉन्स है उनको कहना है फोटो इलेक्ट्रॉन्स. और ये जो फिनोमिनन है दिस फिनोमिनन इज नोन एज फोटो इलेक्ट्रिक इफेक्ट. ठीक है, इसको अपन फोटो इलेक्ट्रिक इफेक्ट ऐसा कहते हैं. अंडरस्टैंड? हाँ, इट इज ऑब्जर्व दैट फोटो इलेक्ट्रिक इफेक्ट में क्या ऑब्जर्वेशन किया गया है? An increase in the intensity of incident light does not increase the energy of the photoelectrons. It is only increases the rate of emission. ठीक है, देखिए here we can say that यहाँ पर जैसे अपन कह रहे थे कि We can say that if an increase in intensity of incident light, this intense incident light, if we increase the intensity of incident light, it does not increase the energy of the photoelectrons. Photoelectron जो है उनकी एनर्जी नहीं बढ़ती है, इट इज ओनली इंक्रीज देयर रेट ऑफ इमिशन. रेट ऑफ इमिशन जो रहेगा वो लेकिन क्या हो जाता है, बढ़ जाता है. एंड secondly, the kinetic energy of photoelectrons increases linearly with the frequency of the incident light. If the frequency of incident light is decreased below a certain critical value, that is the threshold frequency, no electrons are ejected. No electrons are ejected. The kinetic energy of these photoelectrons increases, no doubt, linearly with the frequency of incident light. Understand? The frequency of this incident light. This is not the incident light. So the kinetic energy of that photoelectron, it is increases linearly with the frequency of incident light. If the frequency of incident light, if the frequency of incident light it decrease below a certain critical value, that is threshold frequency, no electrons are ejected. इसलिए ये जो बीम ऑफ जो लाइट फॉल कर रही है मेटल पर, इसकी फ्रीक्वेंसी कैसे रहना चाहिए, सफिशिएंट रहना चाहिए, sufficiently high रहना चाहिए. Then the electrons are ejected from the metal surface. Otherwise, no electrons are ejected from the metal surface. So Einstein in 1905 explained photoelectric effect. आइंस्टाइन ने जो फोटोइलेक्ट्रिक इफेक्ट एक्सप्लेन किया है, क्या कहता है आइंस्टाइन? ए फोटोन ऑफ इंसिडेंट लाइट transmits energy to an electron in the metal surface which escapes with kinetic energy. देखो, a photon of incident light क्या करेगा? Transmits energy to an electron in the metal surface and which escapes with kinetic energy. And second जो है, in order to release an electron from the metal surface, the incident photon has first overcome the attractive force exerted by the positive ion of the metal. ये दो ऑब्जर्वेशंस किसने किया है? आइंस्टाइन ने. क्या कहता है आइंस्टाइन? ए फोटोन ऑफ इंसिडेंट लाइट transmits energy to an electron in the metal surface which accepts with kinetic energy. Or second, he can say that order of release of an electron from the metal surface, the incident photon has first to overcome the attractive force exerted between the positive ion and the metal. The energy of photon is proportional to the frequency of incident light, and the frequency which provides enough energy just to release the electron from the metal surface will be the threshold frequency. तो अगर थ्रेशोल्ड फ्रीक्वेंसी अगर कम है ना, दिस इज नथिंग बट म्यू जीरो, तो देयर इज नो इजेक्शन ऑफ इलेक्ट्रॉन. इलेक्ट्रॉन कोई भी इजेक्ट नहीं होते या इमिट नहीं होते इलेक्ट्रॉन्स मेटल्स. यानी कि वी कैन से दैट थ्रेशोल्ड फ्रीक्वेंसी शुड बी दियर. देखिए, जो फोटोन जो मेटल पर गिर रहा है उसकी जो फ्रीक्वेंसी रहना चाहिए वो थ्रेशोल्ड फ्रीक्वेंसी के बराबर भी रहना चाहिए. फॉर हायर फ्रीक्वेंसी, देखिए, इफ म्यू इज ग्रेटर देन म्यू जीरो, a part of the energy goes to lose the electron and remaining for imparting kinetic energy to the photoelectron. Thus, we can say that h mu is equal to h mu 0 plus 1 half mv square. So, ये h mu 0 is nothing but capital W, that is nothing but work done. If you put here h mu 0 के बजाय अगर आप W रख देते हैं तो आपको मिलता है h mu is equal to W plus 1 half mv square. और अगर अपन W को ट्रांसफर कर दे तो क्या हो जाता है? एच म्यू माइनस डब्ल्यू इज इक्वल टू 1/2 एम स्क्वायर. तो हियर दिस एच म्यू इज नथिंग बट एनर्जी ऑफ इनकमिंग फोटोन. एच म्यू इज नथिंग बट एनर्जी ऑफ इनकमिंग फोटोन. एंड दिस एच म्यू जीरो, जिसको आपने कहा है वर्क फंक्शन, तो इट इज नथिंग बट द मिनिमम एनर्जी फॉर एन इलेक्ट्रॉन टू एस्केप फ्रॉम द मेटल. एच म्यू जीरो इज नथिंग बट minimum energy for an electron to escape from the metal. So if you plot a graph of kinetic energy on y-axis versus frequency on x-axis, तो we can get a straight line graph. आपको एक स्ट्रेट लाइन ग्राफ मिलता है. एक्स एक्सिस पर क्या लेना है, फ्रीक्वेंसी म्यू, और वाई एक्सिस पर काइनेटिक एनर्जी, सो दैट वी कैन गेट ए स्ट्रेट लाइन ग्राफ. ठीक है. तो हियर द स्लोप, दिस इज नथिंग बट द स्लोप. तो स्लोप इज नथिंग बट एच. स्लोप जो है ये इट इज नथिंग बट एच. एच यानी कि प्लैंक कांस्टेंट के बराबर आना चाहिए. एंड दिस म्यू जीरो, ये जो आपको म्यू जीरो दिख रहा है, इट इज नथिंग बट इंटरसेप्ट. म्यू जीरो क्या है, इंटरसेप्ट है. ठीक है. दिस कंप्लीट अबाउट Planck's this complete about photoelectric effect.